All right, so this is just a quick go at the first problem from the homework, little solution. Remember that we started all of this with this idea of a square, all right? And we said that this square has some side and that the area of a square, if we said this side is 1 unit, then the area of this square is going to be just that side squared. We carried this forward into a rectangle where we end up with kind of different length sides. So maybe this is one side and this is like 3 of those units. Then we said that the area of this would be the product of those two things. Now remember, we said that this is 1 unit. This square is 1 unit squared. So really what we would have is like 1 by 3. So area will equal the base times the height of a rectangle. All right. And those were kind of our founding principles here with these area problems. And so now what we want to do is take that forward into more complex shapes. So let's look at again, we'll start with a rectangle. We know that this area of the rectangle is base times height. And then we just come along and maybe draw in, another little boundary like this, and we see that this is a right triangle. And then we can say the area of the triangle is equal to, well, if this whole thing is base times height, then if we're just looking at this piece here, it's going to be 1/2 base times height. Okay. So now we've got our area of a triangle, and come back in here. Okay. The next thing that we want to do is we want to figure out how to understand the area of a parallelogram. So that is just coming in with a little different shape here, right? Something like this. And what we're trying to recognize is the relationship of these triangles here. So, this is some base in red, and this vertical piece is what we're talking about as the height, right? Same thing here. It's this. Well, we could take this triangle that's missing from over there, lop it in over here, and we have now, right, a rectangle. And we haven't altered the base because we took this piece and put it back over here. So it's still a base B, and it's just a height of h. So the area of a parallelogram is base times height. But again, the height is not the length of this side, it's the height of the perpendicular. Next, we had to look at the area of a trapezoid. So let me redraw a picture here for this. And yeah, so we'll start with our rectangle. And we say a trapezoid, we're going to drop some other pieces here. Like this, and let me make that come together here. All right. So this is, and again, like I'm assuming that these are equivalent, but this whole length is what I'll call base 1. And this length is what I'll call base 2. So if we recognize these pieces as the difference between base 1 and base 2, right? Base 1 minus base 2 would equal that difference. And if I take this triangle and again chop it off from the left side here and put it here, right? We've got a rectangle. So the question is all right, well, this side is base 2. How much do I have to add to it to get this full side, right? Like base 2 plus what? Well, that's base 2 plus, right? The difference between base 1 and base 2 divided by 2, right? So if we simplify that so that we can get this side here, right? Let's go ahead and rewrite this as, see if I can do this. Oh, yeah. Base 2 over 2 plus base 1 over 2 minus 2, minus base 2 over 2. Sorry. This should be 2 base 2 over 2. And then we can combine these two guys, and we get base 1 over 2 plus base 2 over 2, and that's the length of this side, this whole side now. And we know the height is h. So what do we have? Well, right, we can clean this guy up and call him 1/2 base 1 plus base 2 times the height. And voila, there's our area of trapezoid. That's problem 1.